Welcome back to my channel, everyone. Street Tips here, and today what we're going to do is take a detailed look at my silver cell. This is a stainless steel bowl that I bought at Kmart about 12 years ago, and there's some numbers on there. I don't know if they're still valid, but this is a non-magnetic stainless steel mixing bowl. You can see there it's 9.5 inches on the outside rim. Now we'll put our ruler here on the table and get a measurement on the bowl. You can see there it's 5.5 inches from the surface of the table it's sitting on to the rim of the bowl. I'm not sure what grade of steel this is, but it's definitely non-magnetic. Here's a magnet. Doesn't stick, but it will pick up my tool here. So you want to check and make sure that the stainless steel bowl we're using is not magnetic. This stainless steel bowl will act as the cathode for the silver cell. And what I've done here is I've manufactured a piece made out of copper. It was a copper strap that was about 4 inches wide, and I just cut it with a pair of tin snips and manufactured a cathode connection for the silver cell. It will fit right up here just like this. Let's take a look at this cover that I made for the cell. What I did was I took my stainless bowl and I put it upside down on this piece of plastic cutting board, and then I drew a circle here, and then on each of 4 corners or 4 areas adjacent to each other I drilled some small holes, and these are locator pins that I installed. They're just pieces of bamboo skewer, non-reactive, and what this does for me is this allows me to centrally locate the cover on top of the cell so it stays in the center of the cell. Let me set this over here out of the way. I set it inside of a Pyrex dish in case it gets jarred and some of the electrolyte spills out. I've got a dish under there to catch it, and this is about 3/8 of an inch thick piece of plastic cutting board, and I found one at the thrift store. This would be ideal to be used as a cover for the electrolytic silver cell. Now this has a little brand name tag on it right there, and the way I connect the cathode connection to the stainless bowl is I've got a hose clamp in here, and we just slip that up, let me see here, over the bowl like this, and then I slip the rubber or the copper piece that I manufactured under that, and then we use a wrench over here and we tighten up this hose clamp. Not real tight, just tight enough to make a good connection all the way around the bowl so that it doesn't fall off. There we go. Now we got a good tight connection for the cathode. Here's our cover. It's made from a cutting board. Fits on the cell like this. And then there's an opening right here where I can service it, stir the electrolyte, or add more electrolyte to the cell, because the electrolyte level drops as the cell operates due to evaporation, plus the concentration of the silver in the electrolyte depletes as the cell runs. It plates out as pure silver crystal on the inside of the cathode stainless steel bowl. So the concentration and the actual physical level needs to be adjusted as the cell operates to ensure we got the proper concentration of silver in our electrolyte and the proper level, physical level of the electrolyte is maintained in the cell. These are the little cups that I use for the anode basket. They hold up well. They're made out of good material that doesn't deteriorate, and it's got a snap-on lid that can be used to hold the filter in place. And what I do is, here's one that I have that's used. I cut some holes in it, and then we cut out the center of the top so that it fits down onto the cup, and then we can put our filter in here and then use this ring as a retainer to hold the filter in place. I always keep the silver cell covered up to prevent any foreign material from falling down in there. What I have here is just a piece of 10 gauge wire. It's got a loop formed on the end of it. It's about 2.5, 3 feet long. And if you look up here, I've got a power supply. It's a DC power supply rated at 30 volts and 10 amps. The cathode connection is the negative pole on the power supply. So I just insert this wire onto the negative side and tighten it up nicely. Now if I follow this lead down to the silver cell down here, you'll notice that I have a little brass bolt with a wing nut, and I just use this to attach it to the cathode connection that I fashioned out of the copper strap. Now I've got a good secure connection between the stainless bowl through the hose clamp down there and the piece of copper strap bolted to the cathode lead that's hooked to the negative side of the power supply. Here's the filter bags that I like to use. They're made out of Dacron. There's a number down here. I get these at Ace Hardware. They used to be like about $7, but now they're 10. And what we do here is I just cut the bag open, get the filter out, and then it's a vacuum cleaner Dacron filter bag. And I turn it inside out here. Make sure the tag is out of the way and all the filter or the seams are out of the way. We take our filter basket. That's the retainer ring. It's just the cup or the top of the lid for this container, and I cut the center of it out to make this retainer ring. This one's getting old. I need to replace it soon, but we're not going to do it for this video. And then what I do is, once I've got all the seams out of the way and the tag out of the way, this is an old paper towel holder, and I just kind of stuff it down in there real good. Now what I do is I just hold the tube. Well, first we put the retainer ring over the tube like so. Hold the tube with my chin so that the filter stays in the bottom of the container down there, and then place this retainer ring and snap it in place. So now we have a suitable filter for the electrolytic silver cell. Now what I'll do is I'll use a razor and we'll cut the excess material away from our filter basket. Now we've got the anode filter basket prepared. What I have here is some impure silver granules. I made these by melting some cement silver from my gold refining operation and then pouring it into water to form these granules. This is about 98 to 99% pure silver. We're going to fill up the anode basket now with the impure silver granules. You may be asking, where do we get the impure silver granules? And the answer is, if you look over here, I've got some silver, some cement silver in this jar. That's 98 to 99% pure silver powder. And where'd that come from? Over here is my silver jar for my gold refining. So we have some silver nitrate solution here that we poured off and recovered from the inquarted gold. We inquart the gold with silver, sterling silver, and then we pull it back out with nitric boils. I add it to this jar, and then I add some additional pieces of silver so that all of the excess nitric gets consumed. And then I take this solution and filter it, and then I add pieces of copper to it and cement the 98 to 99% pure silver powder out of this solution onto pieces of copper in this jar. What I do then is rinse the blue liquid off of the silver, and then we dry it off in these pans. And I've got two pans here that need to be put up right now, and then I just stick them in a bucket like this and store it. And then what we'll do is, once we get enough, I've got 3 of these buckets now. I've got about 100 pounds of silver powder that needs to be processed. And then once we get all the blue liquid rinsed off of the silver powder, I melt it up into granules like this so that we can run it through the electrolytic silver cell. And then once we do that, it plates out on the inside of that cathode as high purity silver crystal, just like you see right here. This is high purity elemental silver. Every pure silver bar or pure silver round coin on the planet began life as pure silver crystal, just like you see right here. What I have here is some pure silver crystal from the previous run. This is about 600 grams of pure silver crystal dissolved in nitric acid, and you can see it's clear and colorless like water. And there's a little bit of extra silver left down in the bottom. That's to ensure that there's no free nitric acid in our electrolyte. We don't want a whole bunch of nitric acid in the electrolyte, because then it will have a tendency to dissolve the metals that get trapped in the anode filter basket. And then those metals, mostly palladium is what I'm worried about, can become dissolved, travel down through the electrolyte, and begin to plate out with the pure silver crystal. So this is what we're going to use for the electrolyte for the silver cell. Okay, what we'll do is we'll go ahead and filter this electrolyte. I've got a filter set up in here. This will filter out any junk out of our electrolyte. This is a little bit of gold that I dissolved earlier to clean up some of my glassware. This will go in my waste container. I'll recover it later. But for now, I'm going to get it out of the way. Now what we'll do is add some distilled water to the remaining silver in here. Now I'll add some nitric acid to this silver, just a little bit, maybe 50 milliliters, and we'll dissolve the rest of the silver that's in this jar, and then use it to augment our silver cell electrolyte as the cell operates. When this reaction is complete, what I want to end up with is just a little bit of silver crumbs left down in the bottom of the beaker to ensure that I've consumed all of the nitric acid in here. Occasionally I overshoot with the nitric. All the silver dissolves. So what I do is I've got some silver set aside here, and I just add a little bit more silver until all the nitric gets consumed in here, and there's a little bit of silver crystal left down at the bottom of the beaker. Here you can see our silver nitrate solution is colorless, clear like water. There's nothing in our filter, so we're just going to rinse this out, get all the rest of the silver nitrate rinsed out of the filter and down into our flask. One other thing before I get too far along in this, if you look, the piece of silver is marked sterling on the back, and as long as it has that mark, you can pretty much count on it being made of about 90% silver, 10% copper. I know sterling is supposed to be 92.5%, but I evaluated at 90%, and the silver can be held just like it is here. You do not need to refine it into high purity silver crystal. If you choose to hold your silver in this form, sterling silver, 925 silver, then leave it just like it is. Don't try to melt it. As soon as you melt it, that mark gets destroyed, and then its value and its silver content becomes questionable. So if you leave your sterling silver in this form right here, you can hold the sterling just like it is. You don't have to refine it. Alright, what we have here's our bag of sterling silver. Let's throw it on this scale. It's 4,124 grams. So if you look at that, 4,128 grams times roughly 0.9. So there's 3,700 grams of pure silver in this material. Divide that by 31.1, and we've got about 120 ounces of pure silver in this material here. Now we'll take the cover off here, set it aside. And I've got our electrolyte that's been filtered. We're going to add that right into our stainless steel cathode now. I've got a glass rod here. Put that down into the electrolyte, distilled water, and we'll add some distilled water now and top this thing up to about within 1/2 inch of the rim of the stainless steel bowl. Now let's carefully install the cover on here. I've got the 4 little pegs sticking down made out of bamboo skewers to locate the hole directly over the center of the cell. Now we're going to drop the anode filter basket in here. The bottom of this anode filter will be suspended in the electrolyte in the cell. And we'll cover this up, make sure nothing falls down in there. Here is the anode connection. It's just a piece of 10 gauge wire, and I've cast a pure silver bar onto the wire, and this will act as our anode electrode bar. We're going to connect the anode bar to the positive side of the power supply. I've got the anode connection kind of coiled up a little bit to form a little bit of a spring, and that will help force it down into the anode filter basket and press the silver down as it dissolves. Here's our anode bar. We're just going to set that into the anode filter basket just like that. I've got everything configured. Got the anode basket full of impure silver. Get the anode bar down in there, pressing it down into the filter. Got our cathode connection. If you look down in here, the anode filter basket is submerged in the electrolyte. So now what we're going to do, I've left it in there and let it soak for a few minutes so that the electrolyte soaks down into the anode filter material and comes in contact with the impure silver in there. So let's hit the power supply now and see what kind of readings we got. We want to maintain 3.5 volts here. Alright, I think that's good right there. Took a while to get it dialed in. 3.6 volts, 1.13 amps. And now we have the silver cell in operation. If you look down in here, we might be able to see some tiny crystals forming in there. Not yet, I guess. It's going to take a little while, but if we come back in about an hour, we'll be able to see some tiny silver crystals already starting to form on the inside of the stainless steel cathode. What I'll do is, after a day of operation, the silver will dissolve in that anode filter and that level in there will drop. So I just pick it up off of there like this, set it off to the side, come down here and get a little bit more of the impure silver shot granules, and then just add it to the anode filter basket. And then replace the electrode bar. And then we'll just keep doing that for the next 10 days or so. And after about 10 days of operation, we'll end up with about 1.5 kilos of high purity silver. And the way this works is the electric current goes down through this electrode bar, makes contact with the impure silver in the anode basket. It's in contact with the electrolyte down here inside the cell, and the silver ions, as they dissolve, they travel through the electrolyte and then plate out on the inside of the stainless steel bowl, and then the cathode connection here completes the circuit back up to the power supply. So the conclusion here is, we take the impure cement silver that we've melted into granules, feed it into the electrolytic silver cell where it gets dissolved in the anode filter basket. By the way, any other precious metals such as gold and platinum group metals that are in that impure silver will get trapped in that anode filter, and then we save those filters and process those for the precious metals that they contain. And then after about 10 days, like I said, what will happen is we'll end up with about 1.5 kilos of high purity elemental silver metal. I've got the power supply straightened out now, and if you look down in here, it's been running for about a half an hour now. You can see there's some pure silver crystal starting to form on the inside of the cathode down in there. This cell produces about 5 troy ounces of pure silver per day. That's about a half hour's growth right there. Okay, this will conclude the silver cell video. I'd like to thank everyone for watching.